Assalamu alaikum. Good evening, Mr. Flex. Thank you for joining the class. So today is our 13 class, class number 13. We have only 7 classes remaining after that one, and today is our third lecture regarding the PVsyst software. Basically, yesterday I just recall the previous one. Yesterday we just check the interface of the PVsyst software, how we will start the new project, how we will import the component, import the projects, and export the component, export the projects from the PVsyst software, how we will start our new project, how we will set up the TMB file or like the any locations through the weather files, weather data, and the system definitions and the unlimited tracker and shares multiple things we have do in our yesterday lectures. So from today we will discuss about the losses which we have to put in our in our PVC simulation report, and from tomorrow and the remaining lecture, which is on the Monday, we will do the simulation for the different projects and different things. So it is just the recall of the yesterday lectures. I have question to everyone. Uh, have you understand the interface of the PVsyst? Yes or no?
For interface, I understand it.
Okay. Mudassir Wakar.
Yes, sir. I understand because I have worked before on that interface, but unfortunately for the last two classes I was not available due to some issues. So yes,
Okay.
I know.
Brother, sorry for the yesterday lecture. I don't have time to upload the recording. So tonight I will upload the recording and share in the group. Unfortunately, today I'm too much busy on my project working. That's why I can't upload the recording of the yesterday lectures. So, Mr. Khurram, how many year of experience you have working on the PV system? Khurram, that's it. How much year of experience you have working on the PV system? Any experience on the PV system?
Generally, I don't have any experience, but I did some experiment projects during in one of the session. So at that moment, I used this PVC software. After that, I often use it occasionally, but not in general practices.
Anyone from your side which are working like the doing the job, or all are you are students? I think Mr. Khurram, sorry, Mudassir, you are the experienced guy, I think. 7 year of experience, I think.
Yes, sir.
And Khurram, Ismail, I think Ismail in the study phase and like in the, and Khurram, you are experienced guy, or you are like the in study phase?
Yes, I'm not studying. I have just now experiencing, but in field mostly.
Okay, as side job,
Started planning.
mostly.
Yes, yes, side job.
Okay,
Side job. Yes.
okay. And Vakar, your job.
Sir, I'm in studies phase right now.
Okay, BS or MS.
No, sir, I have done bachelor electronics. Right now, I'm doing job in a local company for the tender engineer.
Okay, tendon engineer. Okay. And Mr. Flex, your job.
My job for the moment, I'm rear electrical engineer in one company. I'm on charge to design solar plants, overhead line, commissioning for some small utility. That is
Okay,
my role.
okay, that's great. So now we will move to our today lectures. Can you see the screen right now?
Yes.
Yes, sir.
Okay, that's great. So basically, yesterday we have studied about how we will set up a system like the number of inverters and the number of panels per strings. We have checked that. Now today we will discuss about the losses. Yesterday I have discussed about this field thermal loss factor, but from now on we will discuss about the ohmic module, soiling, IME, and auxiliary and other things we will discuss today, and we will complete our share PVsyst report.
Please, sir.
Basically, sorry.
It possible to return on orientation if we have many orientation to how to design it. That parts.
Okay, no issue. I will just basically you can see that there are the multiple orientation available in our system, like the PV system. First of all, in the fixed tilt plane, just give them the fixed tilt, and if your system is have some azimuth, like from the tilted to the side from the exact south direction or north direction, and just give them the tilt angle. How many the tilt angle is that? Then the several orientations in that options, which I have already like discussed that we have different, like in that we just do maximum 8 strings, 8, and can see that you can see that we just give them the 6 orientation at that time, not maximum that in that orientation. So it is basically option in yesterday I have discussed in the lecture regarding the MPPT use of the inverters. So here is the case like that. If some PV modules had different orientations, like east-west directions, PV modules are installed. So in that case, some PV modules are oriented in the east direction, some are in the north direction, some are in the west direction, some are uh, in the uh, mm, sorry, north, south, east, west direction. So there are the multiple options like in the PV sheds area. So now what we have to do, we have to give them the azimuth as per their orientation, and if they are in the fixed, their tilt angle is the same. So is one option is that. The other option is that we have different tilt angles. Like some PV module installed at 5 degree, some are installed at the like you have seen that in the area, like in the utility scale projects, we have seen that a customer will in some panel will install on the rooftop, some are installed on the sheds, so they have different orientations, tilt angles. So we should define the tilt angle and the number of panel as per their tilt angle and the number of panel as per the different tilt angles. So in that case we have different orientation available. So then we have to use the different MPPT options of the inverters and occupy all the number of MPPTs, and then it will be okay.
Oui, ça va. C'est parti.
Okay. Okay. And then the seasonal tilt adjustment, I have just sent that we have different orientation like in the winter and summer, but these are not mostly used because we have to adjust. If we use that option, we have to adjust after some month. We have to change the tilt angle of the structure, or it is not possible. And then the unlimited shares. Unlimited means that like the ground mounted systems, and in that case we have multiple number of structure available at the same level at the same pitch, and then we have to use that options. And unlimited sun sheds, like the PV modules installed in that direction, you can see that, but these are not used properly, these are not used. And then the tracking angle options, unlimited tracker horizontal options. If we have the system like large scale project and the PV modules are installed on the tracker system, we have to use this unlimited tracker options. And other options are like the tilt angles, axis tilt angle. This is option is used for the tracker because the tracker has the different options of the different maximum and minimum tilting angle, like the 60, 55, because you have seen that the tracker will rotate from some minimum angle to the maximum angle. They will rotate in the as per the sun rotation. And then the vertical options, like slide view, like this type of option. And then the sun sheds. These are mostly not used. East-west directions. Like this, these are option are used mostly for the uh, field tank and the tracker systems, east-west directions, and the tracking in the north-south direction, like in these directions. So most of, but we mostly use the unlimited trackers, or we use the unlimited sheds, or these several orientation options. Mostly these are the used in our system. So here we use unlimited sheds options, and I have given that options. Okay, Mr. Flex, now it's
Ye-
clear.
Yes, it's clear, but I have, in your experience, we can have a plant orientation east and west. I think
Yes, I have.
on
Yes, yes. East-west basically, the tracker will be used the east-west rotations, and we have installed the east-west panels on the PV shed type structures, like the metal sheet sheds type structure, mostly in the like in the USA, and the like the snow areas where the snow is more than, and the rooftop are in the tilted shapes.
okay, but I hear that
Oh,
if you are on a north hemisphere, you need to put to orient your solar panel on south, and if you
yes,
are
south.
you are in hemisphere south hemisphere, you need to orient it on north.
Yes, mostly basically these orientation are the orientation where we get the maximum output power. But you can install the panels in the north facing and in the east west direction facing. You can install the panels, but the output will be decreased through that options.
Okay.
Okay,
Thank you. Mm.
thank you. Okay, now we will move to our today lectures. So here is the option of the DC circuit ohmic losses for array. Now we have to decide the DC loss factor. And the purpose of the cable sizing before that is that we have to decide that how much DC loss is available in our solar systems. Okay. Now, what is your duty when you are doing your PVsyst? You have to do the first cable sizing as per their actual length, as per their side, as per their vendor data, and find the total average loss of your solar systems. Okay. And then you should put that value in your simulation. But you have to give some margin in your losses. Like if you are getting the average loss of 0.6 or 7%, you have to put the value around 1, 0.9. You have to put 10 to 15% margin in your losses, because maybe in future when you are installing our solar power plant, your cable length will increase due to some reasons, so when we have margin in available in your losses which you have put in your PV system, you should uh, save from the LD option. LD, uh, like the large scale project, we have to face the LDs options, because when you are not when your testing is available on site and your system is not generating the PR as per the required value, like you have committed 85% and your system is not approaching this value, you have to pay some amount to your client. You are as a contractor and you have to pay some amount in the form of LDs, liquidity damage like values. So when you are doing the simulation, because you are depending on the weather data, which is basically unacceptable things. You have not a control of that, and it will change in the future. So you have to put the margin like the 10 to 15% that uh, in the losses option. In my experience, if we put that 1% DC string loss, our average loss is around 0.7 to 0.8% mostly. Like 20% we have put the margin available there. You and our company will communicate with the client and say to him that we have margin there, but this loss is achievable as per the average basis. But in the PVsyst is clear that we have to put the average losses of our overall plant, not the one like option that. So we have to put this loss. If we are using the central options, we have to put that loss in the option of uh, 1.9 to 2%, like in between. And if we are doing the string configuration, string inverter, you should it values lie between average 0.8 to 0.9 to 1%. So we have to put 1% loss if we optimize our cables and other things. But if your inverter install another corner of the buildings and your system is installed like the 200 kilometer uh, far from that inverter installation, then definitely your the cable loss will increase. So you have to do the proper installation of a solar power plant, and you have to install the inverter near to your DC string options. If you have this constant value, you should put that one option. Another option is that you should click on that, and you have to give them the length, the string PV module connections length, like that option, and main box to the inverter, this option. You should put that value and give that value. Other option is that group of the parallel strings, like if you have the combiner boxes is available there, you should do the like that options, and then you have to put that value, and you will get the total loss. But if you have not that option, you don't want to put the length, you have to just put that value. Then we move on to the AC circuit, AC losses for after the inverter. Basically, in the central case, we have just, because the inverter are installed near to the our LV switch gear and the transformer. So no cable will be installed because it is the centralized containerized solution. Inverter will be installed in that same cabin where our inverter transformer is available. So here just 10 to like 10 meter or 6 meter, 7 meter bus bar is available, connection available. But in case of the string inverter, the basically the string inverter installed in a field, and transformer installed at some other location. So we have to do the cabling in between, from that string inverter to the LV switch gear of the your transformer. So in that options, your cable have some losses available. So you have to put that losses in your calculation and simulation options. That, but as per the IC standard 60364, the light load has the losses up to the 3% to 5%. But in inverter cases, the client and the consultant, owner consultant, I am talking about the owner consultant will not allow you to give the voltage loss or the power loss higher than the 3%. They will just allow that your one cable have maximum this loss. Mostly they will restrict to the 2%, 2.5%, but somehow they will allow us to 3% for the single cable. But for the overall whole power plant, the LV loss, they will allow us to 1 to 1.5% in between that option. So as per my experience, they don't allow us higher than the 1 to 1.5%. They in between, they will restrict to the contractor, that they will not accept the voltage loss higher than this option. So we have to increase our cable sizing to save this loss, to save the systems, uh, and we have to like the oversize our cables. And the other option I have tell you that the mostly in the clients and the owner consultant, they uh, raise the concern that we have to do the thermal assessment of the cable on the fuse ratings, because in the load cases, in the inverter case, it will be totally different, because they have just the relays operation is available. When some output is going, after that they will get some solar input, they will not convert to the ACs, and they will cut off their output power because we have the curtail option is available. But for the load options, we have to do the cable sizing as per the fuse rating. Uh, so in inverter cases, the AC loss is allow in between 1.5 to 1 to 1.5. So we should put 1.5%. Okay. So you have to just select the aluminum cable and you have to check the whole systems because we are doing the whole systems our okay. We have to do the 1.5% loss available. So now the other option is available. Use one or several MV transformer, use HV transformers. If we are connecting our solar power plant and the low voltage options, we have to check our PR at low LV side of your transformer. Then you don't have to insert these both options. But if your PR means the performance ratio is checking after the MV stations, the POC point of connection is POC point of connection is after the MV transformer or HV transformer. So you have to put that in your simulation because they have also some losses available in that options. But if you are doing your termination at low voltage side, then you don't have to include these both options. So in our case, we are considering that we should include uh, MV transformer HV because 10 kV system mostly we assume that it will be terminated at 132 kV system or 66 kV system. So we should include both these losses for your understanding, for your working. So I have clicked on that options and they will just ask me that what is your medium voltage line power, sorry, voltage level. So we should consider that it should be 33 kV. And they ask us to length MV transformer to the injection point. Mean that if we have like two MV transformer available in our system, or it should be three MV transformer available in our systems. So we have to put the cables are the loss of the whole power plant in the MV side of the cables. And it is mostly lie between 0.25 to 0.35%, not more than that. So we should just click the aluminum cables, put the loss 0.25%, and they will give us this length automatically. But we have to just select that how many number of the transformer available in your system. We select that we have three number of transformer available that option. So we just check that option like 2000, 3000. So like that, because we have these options available, or we just check that. Now we have to add the transformer losses in your systems because you are all know very well that your system is basically have the transformer available and the transformer has some losses like they have the losses of the copper losses and the iron losses. Basically, when the transformer in the running phase, they have the some losses, and they are in the no load case, they have the some losses. You have we are already studied these losses, the no load losses and the copper resistive losses options available. So I'm not going to the detail of these losses. You should search from the Google or You have to search from your engineering books. You can study out that. But as per this report, we have to just put that losses in our systems. But my system is like 33 kV system available. I have 3.3 MVA transformer available in my case. So, as per the vendor data, mostly we get that vendor data for each transformer, that how many power iron losses available and how many the copper losses available in your transformer. But as per the hidden trial, uh, like the experience-based system, we have 0.1% loss in the iron phase and 1% in the copper phase. Okay, in the aluminum winding transformer. But for the copper winding transformer, the losses are less than that. So you have to check from the vendors of the transformer. So we have 33 kV system and we have to give them the 0.1%. So divided by 100. So 3.3 kVA is the iron losses available. And for the 1 kV divided by 100. 33 kVA have the losses of the in case of iron. Oh, sorry, copper losses. So these are not the fixed value. We have to check that, and as per our experience, uh, most of the cables and most of the like the transformer have these type of values. Not higher than this. Mostly it is less than that options. So now we should move on to our HV side, and we assume that our system will be terminated at 66 kV systems. And we assume that our system voltage level is 66 kV. And mostly our injection point is near to the HV transformer, like 100 meter, 50 meter. After that, we have to just give them the 50 meter. Mostly the HV cable losses are negligible one that. Negligible one that. But you have the transformer losses available in your, like we should include that it will be 10 MVA transformer available. And their losses are around 0.1% and 0.4%. HV has less losses than MV losses. So 10 MVA means that 0.1% divided by 100, 0.01 MVA. But we have to check these value from the vendors, not from. Firstly, we have to check every value from the vendor, because vendor give you the best value, which they are performing 0.04 MVA. So here is the systems we have defined our losses. Now we move on to the module quality. First of all, the module quality loss. Module quality loss. I have opened the data sheets. One thing I want to show you. So you are seeing that the measuring tolerance and the power selections up to 3%. So we now move on to the our systems and you see that. What is that? You just click on that and you have seen that if the module quality loss according to the PV module manufacturer, PVsyst will choose a quarter of the difference between the value. For example, it is between -3 to +3, like this one. +3 measuring tolerance. -3 +3 means that your systems is in between that options. Like +3 to -3%, they will be degrade or upgrade. Like if you have the nameplate of the 10, uh, 610 PV modules, and 3% of that options 18.3 means 18.3. It is basically it will be go up and go down in that options. 3% means that. Okay. So now PVsyst what will say to you that if, for example, with -3 to +3, it will be 1.5. Okay. And if it will be positive sorting like 0 to +3%, it will be -0.5, -0.75. Negative loss value represent a gain value. So basically, they have not clearly mentioned that quality loss. Basically, we have to check that, but in for that option, yes, power selection. Like I think this one, I think 0 to +5. Like I think it will be 0.0 to 3%. This is basically the power selection value, and I will just check that value from our data sheets which we have prepared on the Excels. I will check again. Give me a minute. Give me a minute. I will share again the value. So now you can see that this value, this value, we have demand from the client side that it will be higher than the 8% or greater than, basically it is not 0.8, it is basically 8%. It is typo error. The client has the requirement that it should be higher than the 8% value. So it is gain option, and this is the value. 0 to 3% is the power tolerance. So we have to put this value. If it will be 0 to +3%, it will be -0.75, or if it will be -3 to +3, it will be 1.5. 1.5 means that it will be loss. -0.7% is means that it will be gain in the power, in the energy numbers. So now I move on to our PVsyst. Quality gain mean that our system will increase some power due to manufacturer power tolerance. So here -0.7. Basically, in default, it is -0.7%. And our PV modules, like we are using 715 PV modules, their power tolerance is 0 to plus 3%. So means that it will be minus 0.7%, 75%. It is the gain. But you have to just give them some margin there. So that is why we should put that 0.6. Now we move on to the LID, which I have already explained that in the first year, they have our panel will degrade 1% N type and 2% the P type PV modules. We have seen that 0.4 to 0.35 is the annual degradation of your PV modules. So the LID should be 0.6 or 0.7. If we consider 0.4%, it should be 0.6. The remaining one should be the LID factor. But we should put that some margin, we should put 0.7% the LID factor. It is the module mismatch loss and string voltage mismatch loss. Basically, module mismatch is the mismatch between your like the pallets available on the when the manufacturer give us the pallets, they give us the the flash test report of your PV modules through the laboratory, and they give us that every PV modules in the pallet have some margin in their short circuit value of the current. So you have to check that the minimum value and the maximum value, and should calculate the difference between these two values, and check that how many percent of their PV module mismatch loss is available in your PV modules. So it is around 0.8 to 0.9% available as per my calculations. And string voltage mismatch is basically, it is the loss available between the strings which are connected to the parallel to each other, like on the inverters. And they have some margin in the voltage drops. Like one string voltage has a length of the 10 meter, the other has some uh, like the 120-meter cable length of their things. But they are connected in parallel to each other on the same inverters. So that is why they have some mismatch available in that. So it should be, we have to check that value. We have checked that value, and it should be like 0.2% mostly. But in case of central inverter, it should be around 0.8, 0.91%. Because central inverter has less options. They have one MPPT. So that is why they have different mismatch options available. But in case of the string inverter, it should be less, because we should connect the nearest length to the same MPPTs. So we have put that value. If you want to see the detailed study, you just click on that options. Now you just give them the wiring length, like we have 140-meter wiring length, and see the, like we have see the and Gaussian, and they have the different options available. Inverter. We have this option inverter row definitions like 20 available and then specify the mismatch. Do voltage drop due to wiring. So we should conclude that value. We should check that value. I will check this value. How we will calculate? I'm some missing the things and tell you about that in the tomorrow class. We should check from that value. They will compare with the minimum length like the 20 meter maximum length. We should put that value and they give us the mismatch in between that values. We should I will check again and how we will calculate that option and let you know in the tomorrow class. So we have to move on the soiling loss. Here is the soiling loss factor. We don't have any specific calculation for the soiling. We have one software PV radar, which I have already discussed in the yesterday class, but they have too much cost of that options. So we don't use that option. So estimated it should be 2%, 3% uh, as per experience base, not a specific value of that soiling loss. So we should just put that in Pakistan it should be three. In South Africa it should be 2%, but in Pakistan it should be 3% because it is a most of the time dust available that and they will give the losses available. So that is why I put that 2% voltage loss. IME just PV modules instead angle loss, auxiliary loss. Auxiliary basically for the large scale project we have to use like the inverter are using their some power. Our system will take the power from the uh, inverter like the UPS systems and other things. We have to use the auxiliary power from your systems also. Like the MV station have the UPS systems available there for their SCADA options and other things. So they will take power from the auxiliary, means auxiliary transformer available there inside the MV skid, and they will charge through that 400 volt transformers. So that is why we have to put just some value for the auxiliary fans, like output power and some night auxiliaries losses available for their through the UPS. So we just put that 10 kilowatt is the just value available. And then the aging tool, aging means that use that option for the simulation for the 10 year, 20 years. We have to check that how they will our system will behave like that. And we will and their degradation of option is available that unavailability that multiple things are available, like you can just if you just click that option you see that there are the different things available in your systems and your system will be unavailable. Like in Pakistan, most of the time you have seen that due to the load sheddings our system will be cut off. Due to some weather issues your system will be cut off. Some of your grid failure, other things, multiple things. When your system will be cut off, then your PR will be down due to that cutoff. So just we just put 3%, 2% as per their client requirement. and they will just tell you. So these are the losses we will put and click OK. And then we perform the simulations. And we have seen that our system will have given us the some PR value, and we've seen that multiple report is available this type of the albedo value, our system like latitude, longitude, the tilt angle, the inverter number, the PV modules, total capacity, and the configuration like the 10%, 10 meter, the spacing between the sheds, and like other things are available. So here you can see that, and uh, there is a loss diagram and other things available. So we have done today one simulation, but some other things are remaining for the other two classes. Like we have to explore these self-consumption options available for the best systems. Like we have the large scale project, we have seen that multiple projects available in the USA, like in UAE, Saudi, South Africa. They have installed the separate best system, which is installed through the PCS software, PCS power conversion, like the options which behave like a string inverter options there. So we should add the best system like storage. We have different options: self-consumption, peak shaving, and weak grid isolation option. So we should use the best for that options. We will explore these two columns in the tomorrow class. And then the main things is the near shading options, which is basically we shall explore and export the DAE file from the or the Colada file from the SketchUp in the tomorrow class, and we will do the shading analysis of our PVsyst software. And this is the energy consumption option available there, because if you have, like I have tell you that in the yesterday class, that most of the system has, like in the large scale grid projects, which are directly connected to the main grid of the country, and the country grid has some limitations, and they will, when they will sign their contract with the grid, the developer of the projects, and the grid operator or grid companies, they will the country operation manager and other authorities, they will sign that how many active power you will provide at any cost, like the 10% voltage up and down. Your system will provide our grid this active power must. So means that as per the grid requirement, you have to give them the active power. Like it is the grid limitation. You should uh, uh, consider is a grid power limitation. Like we have 10 megawatt system, and our system grid limitation is like 9.9 MVA systems. Okay, so now there are the different options. Limit applied at the inverter level, limit applied at the injection point, and account as a separate losses. Now, as per their contract, most of the cases it should be applied at the injection point. Most of the cases account as a separate loss, but you have to do that options for the large scale project, 100 megawatt, 200 megawatt. You have to apply the grid limitations. Okay, so this is the option is available there, and the other one is option is the uncertainty P90 to P50 estimation values. Basically, it is that we are doing our system and putting the losses. Like we have put the 2% loss, the soiling loss. Okay. Now, in the whole year, we have to put that our loss is 2% for the year. And in that whole year, some weather issues, some other things available, and your soiling loss is increased like the 2% because you have just estimated value. You have not actual value. So that is why our system has some uncertainties values available in our system. Like the losses, we have put 1% loss, and your system will be like less than 1% system loss available. So they have some uncertainties available. So most of the lender technical advisors, they will ask us to give the some uncertainty values. So we have to prepare the list that we have put these losses, and as per the standard deviation, these some losses will be up and down. So we have like the 0.1%, 0.2%, 2% uncertainty is available. And so then you have to apply these uncertainty values in that, and your P90 value will become show there. The purpose of this is that as per these uncertainty values, your system will give us that value. It is the 90% chance that we should achieve that value, P90 value. So we should explore these also values, and then we will simulate our systems and other things, like we should apply the different orientations and the tracker systems and other things we should apply in the tomorrow class. And in the last class, I will take some in the tomorrow class, I will give you the uh, task to every person to complete, to make some PVCs and share with me in the group. If if from the class, like the 8 people are 10 people have joining this sessions, and if anyone have missed this uh, like on the weekend, I will give them task, everyone, to make some PVCs and other things. And if you have not done that task on the weekend, I will not give you the certificate of that's uh, that classes. So that, because I have given that assignments in the yesterday lecture, in the previous lectures, but most of the people have not done that assignments. So that is why it is last warning to everyone to do the assignments on the weekends and share with me. If anyone have missed that assignment, I will not give them the certificate of the sessions. So now it's time for your question answer. You will ask the question, I will give them the answer and explain if you have any query. Yeah, Flex.
Yes, sir. I don't know if I was see well on
I think Mr. Flex, your side have some internet issue.
MV
That is,
3000 meter.
sorry.
Yes.
I think you have internet issue. That is why your voice is breaking a lot. Any other? I think Mr. Flex has some internet issue. Mr. Flex, you will ask this or write that question in the chat box. I will see. Mr. Flex, why revenue cable only? If it is we are for 3,000 meter, it means consider the overhead line to the city substation.
Yes, sir.
Uh,
Are you
yes, Mr.
hearing me
Flex.
well now?
Yes,
Now it's okay.
basically, Mr. Flex, I think you have asked the question in the chat box. Why aluminum cable only? Not a mandatory one. It as per your project requirement. It should be aluminum. It should be copper. But mostly in the large scale project, aluminum cable will be using because they are in the cheapest than the copper, and the client will accept the aluminum cable rather than the copper cables. Because if you use the copper cable, it will increase your project cost too much on the higher side. That is why we mostly use the aluminum cable, not the copper cable. And the second point is the injection point. Basically, these all the things which you are asking about me. It basically as per the your project requirements, not an estimated value. Because when you are doing some projects, uh, client will give you the proper ER, the employer requirement, in which they clearly mention that where is your solar power plant installation, the PV area, where is your substation area. You have to connect your solar power plant on that option. This is the length in between. They will totally give you the all the area. But the MV stations is in your case mostly. The 3,000 which I have put that value, it is totally the overall the whole power plant. The MV cable will be used, but I have just put that value in the estimated value, not a correct one. We should use as per your project, your like the systems where the system is installed, the MV cables um, should be traveling. So that is why it's just an estimated value, not a exact value. But I have tell you that our voltage loss is uh, in between that values. Okay.
Okay. For example, if you can return on that reports from PVC's reports, it's possible.
Yeah.
Okay, let's go on single line diagram.
Yes.
Okay. Can you okay, that the injection point for MV transformer is the HV transformer.
Basically, you can see that it is our panels connected in making the strings, then string connected to the inverter, your inverter connecting
Yes.
to the LV switch gear connected to the transformer, 33 kV transformer, and 33 kV transformer connected to the MV switch gear. MV are RMU side. RMU side will be connecting loop in loop out system. Multiple transformer will connect through each other, and then output cable will connect to the here. Here is the 33 kV switchgear available, which basically we connect the 33 MV cables here, and they will connect through uh, through the transformer, and then 30 transformer will step up the voltage from 33 to 66, and then the MV side of that, oh sorry, the secondary side of that transformer, like the 66 panels are available from that. It will be like underground cables, or it should be the overhead transmission lines. It should it as per your project requirement. But most of the connections is the client will give you the overhead connection point in your PV area. So you just connect your system with that option. But maybe it may be possibility that we have to just give them like 1 kilometer or 2 kilometer transmission line of 5 kilometer transmission line. But most of the cases, the client will give you the transmission injection point in your PV area. So
Okay.
you just connect your cables at injection point where your client have given you that value.
Yes, but I need to understand well what is injection points. Let's talk on MV transformer and HV transformer. I think that two equipment must be around your utility plant.
Oh, yes, yes.
Okay, it means the injection points for MV transformer is, I can say, is a switch gear between MV and HV transformer,
Yes, yes.
and the length there must be the distance between the cable between MV transformer to switch gear. That's I must put there.
Yes, yes, yes. You are right.
Okay.
You are right.
Now
This
the injection
3,000
points.
meter, three
Yes.
thousand meter.
Okay. The injection point between transformer, HV transformer. Here inside here we must have a, a pole, HV pole.
Not mandatory that it should be the HV pole. It should be from the client side. It must be HV pole, but from our side it should be cable.
Yes, it can be cable till to that cable must go to pole, HV pole.
Yes, yes. Most of the cases.
And that distance, the length there must be that
I will
under
show
under.
you. I will
Yes.
show you something. Give me a minute. I will show you. I'm unsharing screen. Give me a minute. I'm sure I will show you my show you the journal. So, brother, I have this 72 megawatts of solar power plant. Okay.
Okay.
Now, now you have seen that these are the transformer available, MV transformer. Like we have just connected this transformer to one to the two and two to three, and this will give that cable to that substation area. Here are the 33. These panels are available. Okay.
Okay.
Here, I think. Yes. Yes. The 33 kV transformer available. Okay. Switch gear in MV switch gear room. Okay. Now, we do, we connect that 4 to 5 and 4 to 6, 5 to 6, and then we'll travel the cable. And the same one, we connect the 9 to 10, 10 to 7, and 7 to them. And then we make them 11 to 12. So we have made 4 feeders available in that, and we give them uh, connect to in our switchgear rooms. You have seen that these panels are available. From that, they will make a output panel. From that they will connect with each other, and they travel through that, and they will connect this through the transformer. And it is basically, this is the transformer available, HV transformer, 33 to 66. You can see that the cable tray available there, and you have seen that the input of the cables. Okay. Now they will
Okay.
step up their transformer, like our power voltage from the 33 to 66 voltage level, and we have this high voltage VTA switchgear option there. and we are giving them our connection point of connection in that room. So this is basically the client. The client give us the transmission line connection point in our uh, PV area inside the boundary gantry. These are the gantry options available, and we are connecting in that room. Our transformer, main transformer, and client uh, input cable, like the uh, this transmission lines. So here is the POC value. So you have seen that 20 to 50 meter in between the transformer and switch gears cables are available. So this is basically the concept of the whole power plant. Now I think you have clear that options.
Yes, I'm clear. I'm clear. That is I was asking.
Okay, okay. Now, just I will move on to the Khurram questions. Why will consider more losses in LV side than HV? We also see aluminium cable HV sides rather than copper in Pakistan. Okay. In single line diagram, we cannot mention cable sizes. Khurram, first your question, why we consider more losses in LV side than HV? Basically, in LV side, the voltage is low and the current is high. So that is why the losses are on the higher side. But for the MV, we have the voltages on the higher side and the current on the lower side. So the losses are less. Your question, first answer. The second option, we also see aluminium cable HV side rather than copper cable. Definitely. Uh, because this is the cheapest than copper. So mostly it will be used the aluminium cables. Now in Pakistan and other countries, mostly like outside of the Pakistan, aluminium cable is mostly used. Copper is less usable in that. In PVC single line diagram, I can't see the cable sizes, but in actual when we made on the AutoCAD and other software, we will mention the cable sizes. But in PVsyst, I don't see the cable sizes. That is the three question answers. If you have more, then you can ask. You have asked me the question about uh, you have asked me about the question regarding the PVCAD in the group and Scalian.
Yes, sir.
Khurram, basically, I have get this file of the Scalian from my friend, and I have not installed yet this file. That is why I am not giving you the proper answer of that options. And the second option of the PVCAD, basically, a person has contacted me like 2 to 3 months ago, and they said that I will tell you one website. From that website, you will download the PV Soul and PVCAD in the free. And y- yesterday, I have searched that person and I sent the website in the group. Now, I don't remember that which file I have downloaded. Basically, I have downloaded the files and I have installed that option. But uh, I have lost that value, the data in the download files, which due to the cleaning of my laptop, unfortunately, I have deleted these files. And I don't remember which file I have downloaded, but the file which I have downloaded, they have like the password which I have shared with in the group. This password it will be used, but both the PVCAD and PV Soul are installable, and I have installed these softwares. You can check that option.
Okay, I'm trying.
Okay, brother. But the Scalian, I will install the Scalian for my 2025 version of the software, which I have already installed on my laptop. And if I will succeed to install that option, I will make a short video and share in the group for all the other person for their working.
Please, sir.
Okay, okay.
For me, I still have an issue for SketchUp 2023, but I already installed 2025 and 2021,
Okay,
but
okay, no
still
issue. Okay, 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 no issue. If you have some, basically 2023 has one feature of the Google locations available. But if you have installed the 2025 or 2021, no issue. You should practice on that.
but no Scalion no Scalion.
Oh, yes, yes, I will try. I will try. Basically, these days I'm too much busy because I
Okay.
have to prepare the as-built drawing of my previous project, which we have done our company. And now these days, the client for which we have worked our company, and they are asking us to prepare the as-built drawing of that project. So me and my team are busy in to prepare the as-built drawings and as-built uh, documents. Though, so that is why I'm too much busy and I can't upload the recording and other things that will be missed by these days. So unfortunately, I try to install the Scalian on the on the Saturday, and if I will succeed, I will try to make a short video for that, and inshallah, you will see the result.
Do you have
Okay,
any option when
no
we
problem,
use
sir. When you will be okay, no problem, sir. When you
Yeah,
will be available, will do that for us. Focus on
okay,
your job now. No problem.
okay, okay, okay. Yes, Kurab.
so my question is this, have any options available in Google Earth when we pinpoint the location, can we compass the south, north, east, west?
Google Earth. Yes,
Yeah,
Google Earth. Yes, Google Earth is available. They have south and the directions available. You can see that. Uh, okay, give me a minute. I will show you. Okay, okay. Now you see that. It's basically the Google Earth location. I will search like the where our project is running. Session minus area. So, so here our power plant is actually installing on that mines area. Now you can see that they have the compass available. North is on the upper side and the south on the lower side of that area. Okay,
so where is
Puram?
the show? Sorry, where is the
This
show?
one, this one, this one. Sorry, उर्दू
I
में पूछ
have
रहे हैं कोई मसला
a
नहीं.
Google Earth. सर मेरे पास जो पड़ा हुआ है ना सॉफ्टवेयर ये वाला गूगल अर्थ का, उसमें ये वाला ये नहीं आता, साउथ
नहीं नहीं
टू नॉर्थ एंड ये वाला नहीं आता।
you will install the Google Earth Pro. Okay.
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 Screenshot
And then
this.
check. Okay. Then check again.
क्योंकि इधर इधर आपको पता है कि जो हाउस की लोकेशन आती है वो 2 मरला 4 मरला 5 मरला है, तो वो थोड़ी पथेटिक होती है, तो फर्स्ट इनिशियल हम वहां से उठा के तो उसको स्केचअप के ऊपर ले जाते हैं,
Brother,
तो वहां पे जो है
basically, I will tell you one thing. For the small buildings, like you have seen that it is like buildings available. When we
यस
put that location in the SketchUp, they will show like a in small area. So you have to analyze where your system is installing, which buildings is that. You When you are doing the survey on side, you have to check on the side and open the Google Earth or Google locations and mark the coordinate of that buildings. Then you will see when you are doing on the SketchUp. But if you have not done before the survey, and you should
सर्वे
analyze that which is the buildings you don't recognize that building, because when you see on the Google Earth, it will be showing like the small one. Because I think I will show you like Lahore location, I think, just for your understanding. Lahore, like we just now you can see that there are multiple house available in that regions.
जी जी, मैं अंडरस्टैंड कर रहा हूँ आपकी बात को।
Yes.
मैं ये बात कर रहा था
So
कि एक पहले सर्वे हो गया है, सर्वे के बाद पहले लोकेशन लेने का मकसद ये होता है कि जब हम उसको स्केचअप के ऊपर लेके आएंगे, तो हमारे पास जो है ना एग्जैक्ट उसकी डायरेक्शन आ जाएगी बिल्डिंग की,
yes,
तो
yes,
हम उसको
yes, yes,
करके
yes,
जी जी,
yes, yes,
तो हम
yes.
उसके ऊपर
That's
जो है ना वो फिर अपना वर्किंग कर सकते हैं। आपकी बात सही है,
yes,
मैं
that's
सहमत हूँ
right.
इस बात से कि जो ग्राउंड रियलिटी के अंदर चीजें आती हैं वो ये प्रॉपर तो नहीं बता सकता हमें।
Yes, yes, yes. That's good. That's good.
हाँ,
So you
बाकी
should install the you should install the Google Earth Pro. It will show the
जी
north
जी,
south directions.
बाकी स्केलियन रह गया, वो अगर वो होपफुली हो जाता है तो सही होता है कि चलो वो पैनल्स वगैरह लगा के तो बाकी चीजें जो है साथ साथ वो होती जाएंगी
No,
प्रैक्टिस पे
I
भी।
will try my
हाँ
level best. I will try my level
जी जी,
best to install the Scalian on the Saturday and make a short video, because
जी
these
जी,
days I'm too much busy in the office, in the rooms, because you have seen that now it's time 10:30, and
यस
uh, I have to give some time to my family and other things, and like
डेफिनेटली।
multiple things running in parallel. So that is why I'm too much busy these days, and I have to give them the time. You have seen that it is very responsible job to teach someone, because I have to give some time for ourselves for preparations. Like I have to see the things which are like how this will go, and I have which topic I have to teach to the students.
यस,
Basically,
नो डाउट।
it's my good thing for me that you are all the like the experienced guys, and you should understand my point very well. That's it's good things for me. But most of the time we see that the person which are attending my classes, they are new, and they are unaware of that software and other things. So we have to take these peoples in parallel with the experienced guy to show them how we will do that uh, software analysis, and how we will do this system designings.
यस, यू आर राइट।
Okay, thank you. Okay, guys, I think that's it for the today. We will meet again by the tomorrow class, inshallah. Uh, if you have any other questions,